Okay, good morning, good afternoon, good evening. So, itong lecture na ito, we will be covering our next functional groups or our next organic compounds, which is our alkenes. So, our alkenes, also called your olefin, are hydrocarbons that contain a carbon-carbon double bond. So, lahat ito ay merong double bond. Ang carbon na ito ay merong sp2 hybridization, and the carbon double bond contains lots of electrons ready for binding. Okay. So how is industrial alkenes prepared? So ethylene and propylene makes the simplest alkenes. They are the most important organic chemical that is produced industrially. They are produced through they are simple to produce, and they can be synthesized into other components such as what you see on the screen. So your ethylene can actually produce ethanol together with your acetic acid and all of the possible configurations on the slide. So how are they prepared? Madali lang po silang i-prepare. They are simply prepared by cracking your alkanes. Okay? So when we talk about cracking, it is actually the decreasing the carbon length of a long hydrocarbon. Cracking is usually done in large refineries or cracking plants. So, since taga Batangas tayo, you might be familiar with JG Summit. They have a cracking plant in their industrial sector. So, they produce our alkanes as a byproduct. So, the stability of alkanes. So, if you recall our types of strain, if they are eclipsing, they are unstable. So although the cis-trans interconversion of alkene isomers does not occur spontaneously, it can often be brought about by creating an alkene with a strong acid catalyst. So the trans configuration of your alkene is most common, but it can be also interconverted to a cis configuration if you treat it with a strong acid. So we will now be talking about the different reactions of your alkenes, particularly your electrophilic addition reactions. So first, before we move on, let us explain Markovnikov's rule. So observe the reaction on your screen. So 1-pentene, when reacted with hydrochloric acid, produces 2-chloropentane. It does not produce 1-chloropentane. So Markovnikov rule describes bakit ganon. So why does it form on the second carbon atom but not on the first carbon atom? Or let's look here. Bakit dito siya nag-form, not here? Okay. So Markovnikov's rule is an example of a regio-specific reaction when only one of two possible orientations of addition occurs. So Markovnikov's rule states that in the addition of a acid halide to an alkene, the hydrogen attaches to the carbon with fewer alkyl substituents, and the halide attaches to the carbon with more alkyl substituents. When both double bond carbons have the same degree of substitution, a mixture of addition products occur. Please take note, we are not talking about length of the alkyl substituents. We are talking about the amount of alkyl substituents. So ganito po siya. Ang walang alkyl substituent is CH3. Kasi pag pinakita niya yan ay C bago tatlong H. Okay? Ang sunod pong level ng substitution is C, H2, then C, CH3. So meron kang tatlo. Bale, meron kayong isang isang alkyl substituent. Ang sunod po, so ito yung 0, itong 1, itong 2. Ang unang carbon ay merong dalawang carbon pa naka-attach sa kanya. At kung possible pa, meron pa tayong apatan. So ang apatan nyo will look like this. Tatluhan pala. It can be possible, but it is not possible because wala na siyang pagdidikitan. So hanggang 0, 1, 2 lang po tayo. Okay? So sa isang chain, kapag pinag-compare nyo yung dalawang sides ng double bond, hydrogen will always go to the less substituents, while the halide goes to the more substituted carbon. Kapag magkapareho sila, 50-50. Okay, so take for example this one. So this is your reaction 2 methyl propene plus hydrochloric acid. So tingnan nyo, hatiin nyo yung ating double bond. Tingnan nyo yung dalawang carbon. Okay, ilan ang carbon na nakakabit dito sa kaliwa? Mayroon ka isa, dalawa. So it is secondary. Dito naman, ilang carbon na nakadikit dito? Wala. So it is 0. So saan pupuntang hydrogen? Hydrogen will go to the lesser substituted carbon, while your chloride will go to the higher substituted chloride. That is why you will have a product like this. Okay. Another example, so you have your 2-pentene. So you have one alkyl group on this carbon and one alkyl group on this carbon. Please take note, we are not talking about chain length. We are talking about degree of saturation. So ilang carbon na nakadikit dito? Isa. Ilan ang carbon na nakadikit dito? Isa din. Therefore, it is a 50-50 mixture of products. So you can yield both 2 bromopentane and 3 bromopentane. Okay, so to reinstate our Markovnikov's rule, in the addition of a haloalkane to an alkene, the more highly substituted carbocation is formed as the intermediate rather than the less highly substituted one. And it goes hand in hand with our Hammond's postulate, which states that electrophilic addition to an unsymmetrically substituted alkene gives it the more highly substituted carbocation intermediate, because a highly substituted carbocation is more stable than a less highly substituted one. Okay, so these are the different reactions and synthesis of your alkenes. So this is the reaction map. So your alkenes can yield a halohydrin, an alcohol, an alkane, a 1,2-diol, a carbonyl compound, a cyclopropane or a cyclic compound, an epoxide, a halide, or a 1,2-dihalide. So a simple alkene can yield up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So it can be transformed into 9 other functional groups. Okay, so the first one is the addition of halogens to alkenes. So bromine and chlorine add rapidly to alkenes to yield 1,2-dihalides in a process called halogenation. Please take note, we are using chlorine and bromine gas. So these are Br2 or Cl2. They are not chloride, they are not bromide, they are not hydrochloric acid, and they are not hydrobromic acid. They are bromine and chlorine gas. Okay, so ethylene, when reacted with chlorine, will yield a 1,2-dichloroethane. So the possible mechanism is, so this is rich in electrons. Okay, well, this is relatively balanced in the structure. So since this is slightly neutral, okay, neutral to pareho kasi balanced siya. Ang mangyayari, this can grab bromine, while the bond between bromine and bromine moves to the other bromine atom. What happens is the next one. Let's move to the next structure. Meron kayong bromine na kinabit sa left side. Now, the other side of the carbon bond kanina, nasira, magiging slightly positive ang carbon na ito kasi nawalan siya ng double bond. So since ito ay positive at ang inyong bromine ay negative, kakabit naman ang ating bromine sa carbon na ito, and you will yield this final structure here. Okay, so in theory dapat ganyan ang lalabas, ganyan kasimple ang ating reaction. However, this is not the case. The problems with this reaction is it does not explain the stereochemistry. The reaction occurs with anti-stereochemistry. What does that mean? Meaning they do not form on the same side of the structure. Okay, kung makikita nyo, An example natin on the screen is cyclopentane. When reacted with bromine gas, it will form trans 1,2-dibromocyclopentane. It does not yield cis. Okay, hindi siya on the same side. It is not formed. It is already tested. Hindi siya lumalabas. So bakit ganon? So an explanation for the observed anti-stereochemistry of their addition was suggested in 1937 by George Kimball and Irving Roberts, who proposed that instead of a carbocation intermediate, magkakameron tayo ng bromonium ion. So ito po ang structure ng bromonium ion formed by the addition of bromine to an alkane. So nangyayari, itong ating compound na ito sabay magbabond sa dalawang carbon na ito. So parang bibiyakin niya ito, mabibiyak ito pag sabay siyang magbabond sa ating bromine. Bago yung electron sa gitna ng bromine-bromine bond will move to the next bromine atom, yielding a bromide cation and a bromonium ion. So parang pa-triangle yung kanyang shape right here. Okay? So ang problema here, this is slightly positive, this is slightly negative. What will happen next? Okay. So if a bromonium ion is formed as an intermediate, we can imagine that the large bromine atom might shield one of the molecules. Reaction with the bromide ion on the second step could then occur only from the opposite unshielded side. So pag tinignan nyo yung ibabaw, yung taas kasi, kung sa taas nag-form yung bromonium ion, crowded na dito. It is crowded kasi may bromine na dyan. Wala nang lugar si bromide ion para pumasok dyan. Kaya hindi siya na-form. Instead, sa baba siya titira. Sa baba siya kakabit para kasya siya doon. Okay? So yun pong explanation nun. Hindi pwedeng sabay kumabit ang bromine sa ibabaw kasi crowded na sa ibabaw. So it will only form on the opposite side. Okay, so this is a GIF I prepared. Bakit nagkakaganon? And kaya bakit 1,2 trans ang nangyayari, hindi 1,2 cis. Okay, so another repetition. Okay. Wala, ayaw niya na mag-form. Okay. So, the next reaction is an addition of a hypohalous acid to an alkene. So, it forms a halohydrin. So, yet another example of an electrophilic addition is the reaction of alkenes with the hypohalous acid, like your HOCl and your HO bromine, to yield 1,2 halo alcohols called halohydrins. Halohydrin formation does not take place by direct reaction of an alkene with HOBr or HOCl. However, the addition is done indirectly with the reaction of an alkene with either bromine or chlorine in the presence of water. So, kung kailangan nyo dyan alkene, kailangan nyo rin ng bromine or chlorine at saka tubig. So, dapat it will occur in the presence of water. Dapat aqueous ang inyong solution. Okay? So, this is the general reaction. An alkene reacted with a halogen in the presence of water will form a halohydrin and an acid. Okay, so the proposed reaction mechanism is, again, since neutral ito, bromine-bromine is neutral, the electrons here will grab this bromine atom. Okay, then it will form again yung parang triangle shape natin kanina here. One bond will move towards the bromine to make it electrically neutral, and water molecule, saan galing tong water molecule? Yan yung inyong solution. We'll attach now to this carbo-cation here. Okay, kakabit yung OH2 dito sa carbon na ito. Ngayon, ang mangyayari, carbon, OHH. Bakit ganyan? Hindi siya ay positively charged. Okay? It is like hydronium, positively charged. So, mangyayari, hindi siya stable kasi positively charged siya. Mangyayari, bibitawan ng isang hydrogen-oxygen bond yung kanyang electrons para bumalik kay oxygen. So you will release hydrogen ion. Okay? You will release hydrogen ion and this will become electrically neutral. Again, magiging OH na lang yan. So ano mangyayari sa hydrogen ion na to? Kukunin siya ngayon ng water molecule to form hydronium. Okay? So yan ang ating final products. Kaya siya Halohydrin kasi meron kayo ditong halogen at meron kayo ditong alcohol na form. So ang byproduct nyo ay isang acid like your hydronium ion. Okay? Pwedeng hydronium ion, pwedeng actually hydrobromic acid ulit. Kasi hindi naman a-attach yung isang bromine. Okay? It could be water, it could be your bromine atom which attaches to your loose hydrogen ion. Okay? So this is the reaction. And OH will grab it to make it a hydronium ion. Okay? So this will be the end of the first part of the lecture.